a rotate image. So pretty much you got a 2D array or a matrix, and then you want to rotate it clockwise by 90 degree, yeah. And so the 1 2 3 will become 1 2 3 here, and 369 will become 369 here. So pretty much it turn 90 degree like this, and this is the input and this is the output, and there's more examples over here. Okay, so I already have the answers over here. It's answered by LeetCode themselves, and today I'm going to analyze how does it work behind the scenes and how do they come up with such an answer from scratch. So I'm gonna copy this into here, and I will be writing this in Java. So this will be the sample inputs that we'll be using. So the approach that we try to use here is called a four-way swap. So you are swapping this guy with this guy, and this guy swap with this guy, and this guy swap this guy, and then this guy swap with this guy. So this is called a four-way swap. This is the approach that we're going to use, and it's swapping in quadrant, meaning this quadrant is gonna swap with this quadrant, and then let me use a different color. Swap this quadrant, and then this quadrant is gonna swap this quadrant, and this quadrant, and it's gonna swap this quadrant, and then it's gonna do four-way swap individually, like each element swap with each element, like I've shown you before. But that's the big picture. It's these four quadrants swapping with each other, and then as for the 22, it's already in the right order. No matter how you swap it, the 22 stay still. So you leave it alone. So this is the big picture. So how do we start? Well, to start, I need to print out these index using a for loop. Okay, so I'm trying to print out 0 0 0 1 0 2 2, sorry, 1 0 1 1 1 2. Like we mentioned before, we're trying to swap the whole entire quadrant with another quadrant that will give us a place to start. So the first objective is to print out this guy, and alternatively, you can also swap quadrant like this. This would be one quadrant. This would be one quadrant. This would be one quadrant. But for much easier approach, we're gonna go with this for now. Okay. All right. So I come up with this for loops, and it's printing out 0 0. Yeah. So this is the for loop that we want. Okay. So we accomplished the first goal, which is to print out these guys. You should be familiar with for loops by now. And this is the first objective. We achieved it. Second objective, I'm gonna pick this guy, this guy, this guy, and this guy. I'm gonna write down the coordinates. Okay, so how I got these elements are we are getting it from the four-way swap. From here, I want this guy, and this guy. Okay, so it will become these guys. Okay, so and then another four-way swap is this guy. I want this guy and want this guy, this guy. So this will generate these. This is how I get these. Okay, so so I'm gonna start from the second one because usually the first one doesn't give you a whole lot of values. Um, so how do I get 0 and 1 from y and x? Well, it's probably y, just y and x. And next up, how do I get 1 and 4 from y and x? My guess is that this is x, and 4 is probably n. Well, n is this, because we get from this, okay? From the matrix length minus 1, okay? And then, so this n, this is probably n minus y, because 4 minus 0 equals 4, okay? So, next up, 4 and 3, this is probably also n minus y, and 3 is probably n minus x. 4 minus 1 equals 3, okay? And this is also n minus 3. The 0 is probably a y. So to examine if this formula is right, we moving on to the next elements. This guy, this guy, this guy, and this guy. Okay, so this is how I got these. To examine if it's right or not, we simply plug in the values. So 0, 2. Okay, looks right. 2 and 4 minus 0 equal to 4. This is the same thing, so it's also equal to 4. 4 minus 2 equal to 2. So this is the same thing, so it's also 2. And then lastly, you got a y, which is 0. So it looks right. Everything looks right. Next element. I want this guy, want this guy, want this guy, and I want this guy. So now we up to iterate into this y equal 1, x equals 0, 0, 3, 3, 4, 1, 0. Oh, sorry. 4. I think this is 4, 1. Okay. And 1, 0. Oh, sorry. 1, 0, 0, 3, 3, 4, 4, 1. Okay, so let's examine if the formula is correct. 1, 0, 0, 4 minus 1, 3, 4 minus 1, okay, 3, 4 minus 0, 4, 4, and then y, 1. Okay, the formula is looking right. So these are the formulas that we're working with. Okay. So now that we got the formulas, okay, now that we store temp into, I mean 0, 1 into temp, we don't have to worry about 0, 1 getting lost. So now we will move the 30 to 0, 1. Okay. So 0, 1 equal to 30, matrix y equal x equal matrix 30 and minus x and y. Okay, so now we moved 43 to 30. So 30 equal 43 matrix and minus x y equal 43 is this. Okay, so now we move 14 to 43. 43, 14. Is x and minus y, and then lastly you want to move the 1 to 14, but 1 is where we placed by 30, is move 30 is only moved to here, but we store 0, 1 to temp, so now it's 14 equal to temp. And I'm just gonna copy this over. Alright, now we got the formulas. I'm just going to move this over here. Okay. Now that I paste it into the code, I'm gonna first run the code. Okay, accept it. Now submit. Alright, great, we made it. I've been doing countless amount of math to figure out how the author may come up with this in the first place. And to analyze the time complexity. Okay, as for the time complexity and space complexity, well, you got a nested for loops over here, and nested for loops automatically over n square, and there are no other while loops inside, so the time complexity, this is the time complexity. As for the space complexity, you did not make any other arrays inside. So this the matrix is the biggest storage space. A matrix you use m as a unit, so it's over m time complexity. Okay, because it count for the amount of elements that is in a matrix. So we use M to define the matrix space instead of N. Okay, so that's it. Thank you for watching.